anybody, and that was a relatively easy assignment, so even if we don't get to it, it's not that important. But does anybody want me to review any topic from the whole semester? Anybody but V. Go ahead. You can have as many questions as you want. I was teasing.
So I just want to know that the return, I really confused, like when we need a return and when we don't need a return.
Okay.
So if you can get like a clear example of like
As opposed to like an unclear one. So do an example that makes sense instead of like a more confusing one.
yeah.
All right. Got it. All right.
And then you say something about the display and not display.
Yeah, the difference between returning something or displaying something.
So if you can.
Yeah, I'll give you two examples. Brody, will you hit the third button down, please? Oh, and by the way, I'm just about completely caught up in grading. You should have seen some stuff come through. I think I have maybe 1.5 assignments to finish. They'll be done probably in the hour finish following this class. So then everybody will kind of know what they're coasting into the exam with. And I'll also expand out the hackathon points because right now it's just in a column that's not benefiting you at all. So it'll turn into 3 columns. It'll happen. So then you should see exactly what you got going into the final. Okay. So let's say that we ask for a function that takes in 2 numbers and returns their sum. All right? As opposed to a function that takes in 2 numbers and displays their sum. Just keep a simple little function. So for this one, I might say def add nums, we'll call this add nums1. This will take in an A and a B. And we're going to return A plus B. This guy might be called add nums2, takes in an A and a B, and he might, maybe we say sum is equal to A plus B, and then we say print sum. All right, something like that. This guy is not actually spitting a value out. And let me show you that as an example. So if I say answer is equal to, let's call it answer 1, is equal to add nums 1, passing it, let's see, 5 and 3. And then I say print answer 1, as opposed to answer 2 is equal to add nums 2, passing it 5 and 3. And then I say print answer 2, what will the output of this program be? Well, it'll actually be a little bit more than that. So this program is going to actually print 3 things to the screen. This first line says call add nums1, catch the result inside of answer 1. So what's going to happen there? If I call add nums1, when I pass it a 5 and a 3, what result will be returned here? It'll return an 8. This line right here, this guy returns an 8, and we're catching it right here. That's returning it, not printing it yet. Okay? That's returning it. So this guy right here, this function, he takes in 2 numbers, he adds them together, and he spits it out here. He returns it to whoever called it. In this case, I called it out here. So that guy right there will boil down to an 8. We'll store that 8 inside of answer 1. That's what will happen there.
Sorry, excuse me.
On the very next line, see, that was actually pretty good. He's got pretty loud sneezes. He's got really loud nose blows. I mean, that's impressive. Hey, it's not even a knock. I mean, hey, we all got to do it. If you're going to commit. All right, so this guy, he returns the value of 8. We're capturing it inside this variable. At that point, we can do whatever we want with it. I'm choosing to print it on the next line, but I don't have to. That's an example of a function that returns a value. Okay? Now, add nums2 takes in 2 numbers. I happen to pass it the same 2 numbers. we create a little variable in here. We didn't have to do this part, but I create a variable called sum, set it equal to a plus b, so sum will be equal to 8. Then I'm printing out 8, and I'm not returning anything, okay? But I'm trying to capture the answer that this guy spits out. So add nums2, we'll call that function. It's going to print 8 to the screen, and it's not going to return any value. So what will this guy ultimately boil down to? What value will he, quote, spit out? None. The value of none. In other languages, it's called null or nil, N-I-L. So answer 2 is going to get equal to nothing, none, because add nums2 does not actually return a value. We do not have a return statement in there. Instead, we just do some stuff and we do some printing in here. And we didn't even have to do printing. We could have just done that, in which case add nums2 just does some math and it's done with life. That's it. He didn't print it, he didn't return it, he did nothing. Go ahead.
The print sum right there, if you just call add nums and 5, 3, will it print out the sum too, because you put print right there?
What do you mean? Call add nums? What do you want me to call?
Like if you call that add nums A and B, and then you
Which add nums? I have 1 and 2.
2.
Okay, add nums 2.
But then you said that you print out the sum, so that when you call it in answer 2, will print out the sum for you. But then when you print again answer 2, it will print out none.
Correct. This will print out the sum inside here. This will print out none.
Okay.
So I'll go ahead and run that, and then I'll come to you. Well, actually, go ahead in case it's related to this.
If it's not returned, like for nums 2, it'll just come to none.
It always functions always boil down to a value. That value will at least be none if you never return something. Otherwise, it'll be the value you return.
So in the exam, that's what would write none or 0.
Well, it wouldn't be 0. It would be none. I mean, let me show you here. It'll actually be the word none. Is this desktop or downloads? So there's my 8, because the first one returned the value. Then I chose to print it. The second one took in the 5 and 3, added them together, printed it inside the function. Did not return anything, but I tried to catch the return value, and it got a none because it was a function that didn't return anything. So that's, it's none in this language. In Java, it's nuck. Java, it's null. In some other languages, let's say C, C++, it's null, all caps. In Swift and Objective-C, it's nil. Those are all synonyms for each other, kind of like self and this. We talked about those. They all mean the same thing, but Python happens to be none. And Java, which we'll be doing next semester, is null, all lowercase. All right, does that make more sense for whether something returns a value or displays a value? So you should be able to read code like this and tell me what the output is. And notice that it's completely my choice whether I ever want to print answer 1 here. I can choose to not do anything with answer 1, and maybe I say result is equal to answer 1 times 2. And then I use result for some other math thing later on. At that point, I'm never actually displaying to the user the value, but I'm still using it for some math stuff. So that's why it's, we don't always display stuff to the screen. In fact, maybe displaying to the screen is one of the fewest things, certainly displaying to like the console or something like that is one of the things we do the least often in modern application development, because we're usually just throwing crap on a label or something like that, with graphical user interfaces. Mm-hmm. And pretty soon in 250, we'll be writing our Android applications where, we'll be learning more advanced programming topics, but we'll be doing it in the context of Android programming, which is still just Java. Just instead of creating our interfaces out on the screen, which looks kind of stupid like we've been doing in here, we'll build crappy little Android apps that have buttons and crap like that. And then from there, you'll then know the basics of that. And then if you want to spend more time making cooler interfaces, you then can. Okay, but the focus on the class won't be creating beautiful Android applications. It'll be, here's a strongly typed language using a tool that is something that's heavily used in industry. We'll show you the basics of creating interfaces, but the focus is not on creating interfaces. Like, you're not going to lose points because your interface is poorly designed. We have a human-computer interaction class which focuses on that kind of stuff. Not my cup of tea. Not a lot of computer science people's cup of tea. So it is his cup of tea. So you're pretty good at design, right? You're pretty good at design, correct? Yeah. And Van was pretty impressed. At least that's what it sounded like when he was telling me about it. I think I told you Curcio was impressed by you, right? That's high praise from Curcio. He's almost meaner than me. Okay.
We heard his praise during the presentation.
What's this?
Corey, he was talking about how Curcio
Yeah. Yeah. I think Curcio maybe learned his meanness from me.
Oh, most definitely.
Yeah, I think so. I've been a poor influence on that, on that guy. Okay, other questions, other things you want me to review? We're all good with conversion questions? If you noticed, I put a video up yesterday on general. We had a senior come to me and say, I don't know how conversion works. So for those of you who struggle with the conversion stuff and are too embarrassed to ask, which at this level you shouldn't be embarrassed because you just recently learned it, but as a senior it should be embarrassing. But in any case, that video is up there if you want to go and review that. Remember, we only have two patterns, right? If you go from decimal to any other base, you do the divide, record the remainder thing. Mm-hmm. And you go from any base to decimal, you do the ones place, whatever, times the basis place, times the basis place, times the basis place. Those are the only two patterns we have. And then you just have to know that a 10 is an A, an 11 is a B, a 12 is a C, and so on and so forth. Got it? So no excuse for missing conversion questions. I've reminded most of my other classes this, and I'll remind you again. I might even have said it last class, but when you do conversion questions on the test, show your work. You're significantly more prone to make some stupid mistake under test conditions with anxiety and all that other stuff, and you're stressed out that week. If I only get an answer from you and it's not the right answer, I can't go and see where you screwed up. I can't even tell you how common it is for like your very first line for somebody to say a D is a 12 instead of a 13, which then makes the rest of your math all wrong. And if I don't see your math, I got to take off the points. Otherwise, I might even just put an LOL and not take off anything. Or maybe I take off 1 point, whatever, but that's a significant difference, right? So show your work. You got to do it anyways. Just show it so that if you do make a dumb mistake, you're going to get most of the points or at least provide me some entertainment. It really depends on how, bad the mistake is. Like, I've had students, they couldn't add 3 plus 2. No, I've had funny things because you're in the middle of a test, they concatenate. 3 plus 2 is 32. And I think I maybe even gave them a point of extra credit for that. It was right kind of near the end of the grading. It was pretty funny. Yeah, don't leave anything blank. Okay, if you get desperate, I just don't know how to answer this, come up with something funny. Okay, it's not going to hurt you. I mean, you might still get a 0, but maybe it helps you on the next question that you answer, but it's not quite right, but maybe it's right enough or something like that.
Write jokes on the side.
Yeah, I'm down with that. Yeah, I would prefer correct answers.
Yeah.
As opposed to jokes. Hopefully you don't have to revert to many jokes.
We'll find out.
Oh, and the other thing from the presentations last night, and hopefully from both nights, that I hope many of you've heard me say it to you in class several times, because there's some of you in here who've really got liked the programming and taken to it, and you enjoy it. It's become fun for you, and then there's other folks in here, several of you. So if you're one of these, don't worry about it. If you turn to either side of you, chances are both of them are in the same category. You hate programming because you feel like you suck at it. It's okay. When you're seniors, if you still suck at it, it's less okay. Okay, but several of those people that were on stage yesterday and on Tuesday mentioned, take these programming classes. It's good for you. I was bad at it at first. They become late bloomers. Halfway through 250, it finally clicks, and now they graduate. They're some of our best programmers. It just clicks a little bit late for some people, and that's okay. Got to stick to it. What was it, kind of like the Michael Jordan didn't make his high school basketball team type thing. I'm very aware that you're supposed to still suck right now. So your grade will very likely reflect that. You will earn a better grade in the class as long as you put in the effort and did your homework than you probably numerically deserve. All right? So rely on that. Try not to panic. If you become a senior and you can't convert stuff, now you're in trouble. Because I'll take no mercy on that. Go ahead.
Speaking of the senior STEM projects, what do you think of the Corey and Nick's presentation? Because I don't know, I just felt like, as you mentioned, a lot of presentations just die off after they turn it in. But I feel like theirs and Anna's are one of the few that are going to continue on.
Yeah, good reason for both of those. First of all, and they didn't mention, I think I mentioned it in one of the comments, but they're working with another student from the business school. I mean, they've created an LLC around this. They're going to legitimately build a business or try to build a business around that app. So that app was really not, that's the reason they were allowed to work as a team. Typically, I will not allow groups for senior seminar projects. It just typically doesn't work out very well. If you've noticed in group projects that you've had in school, you usually have one person who tends to do most of the work, because either the other people don't want to do the work, or you have a really good student with some, let's call it averagey students, and the really good student doesn't want to turn in their crap. And then everybody suffers because of it, because those averagey students might really want to put in the effort and learn from it, but aren't given the time of day when they can learn from that better student who doesn't help them. So group projects tend not to work out very well, but they came to me for special permission, but they're trying to turn it into a legitimate business. Right. So I think that's why it seems like it'll flow a little bit more. And I think Annie's will be the same. Annie worked really, really hard, and she would be, I think I mentioned at the presentation, but she would be a good example of somebody who was not strong at programming. In fact, she would still say she isn't as good at programming as she wishes she was. So she got a lot of help and stuff like that, but a lot of students won't ask for that help. I think she really did a good job and put in a ridiculous amount of effort on that project. So then the question is what did I think of Corey and Nick's?
Yeah.
I think they could have done better. They're both pretty bright. I think their app will be very good. I was impressed that they put the machine learning stuff in there. And this is where it becomes kind of difficult in that class, because you have to grade everyone kind of the same. So in context of everybody else, they obviously did great, right? But then you also look at individuals and you kind of know kind of what they're capable of based on maybe what they've done during those 3 or 4 years. And those guys have gone to a lot of hackathons. I've seen them produce stuff in 24 hours that isn't that dissimilar from what they did there. Although there's plenty of behind the scenes things that are far more robust than what they built. But where they did take the risk is in bringing in payment APIs and stuff like that. Those things are more difficult to deal with, and things that you typically don't necessarily get that involved with when you're a student. So it was good. Okay. But I think I said the same thing about Brennan's. Right. So if you saw Brennan's on Tuesday, Brennan is sharp. I mean, he was our outstanding senior and Corey does too. They both have jobs at Acuity before they started their senior year. Well, that's a pretty good position to be in, right? You're making, $60,000+ a year guaranteed, and you haven't started your senior year of school. That's all right. So, I think it was a little safe for him, even though it was a complete project, everything worked, and would have been amazing for somebody else.
So I guess then, if people put in a lot of work in hackathons, making apps and stuff like that, what are things you're looking for senior STEM projects?
Kind of like what I mentioned, like with the payment stuff, challenging themselves with something they really haven't done before. So that almost becomes an individual type thing. If you go to a lot of hackathons, chances are you've integrated database stuff into projects and things like that. If you haven't really gone to the hackathons, maybe you're not experienced with that, and that's a big deal for you. And that's a really important skill for industry. So you kind of have to view it from the lens. Grades don't matter. I mean, it's a necessary evil, but you want everybody to come out of a program mastering the material the best that they can. Getting to the point that they were capable of getting to in those 4 years and setting them up to then learn quickly in the real world. We've seen lots of students who come out who pretty mediocre coming out of school, maybe not where they needed to be, but when they got out into the real world and had more motivation because they're making a paycheck, got into a field where they got more specialized, they became very, very good. Because it was never a talent or an intellectual thing. It was just kind of a bombardment thing where they're surrounded by a whole bunch of other things, not showing up to class. Whereas, if he's making a whole bunch of money per hour, that's less of an option. I have a feeling his attendance will be better for work. That kind of stuff. So, the best we can do is dump you out into society with a skill set, and there's kind of this minimum level of things that you should sort of have. But what I look for is, on an individual basis, is what did you include in your project that took you out of your comfort zone? You heard lots of them mention comfort zone there. So, Annie would be a good example. She hadn't done almost any of those things. And she decided to do 4 brand new things, which freaked her out. But she chose to do it anyways, which is, I think, pretty impressive. Or maybe another student like a Brennan or somebody who did help her quite a bit as well. So you got to consider that too. He helped her with her project and that stuff. But it would have been less of a stretch for him, but no less impressive, right? So, I think that's good. But it doesn't impact their grades, right? I'm going to grade everybody on the same level field. I might have those opinions individual because I have some more experience with certain students than other ones. All right. What else? Anything else you want me to review? Go ahead.
Can we go over recursion, maybe with the factorial example?
Well, recursion's hard.
It is, but I don't.
I don't want to do that.
Did you do it just for me?
No, what I said, I don't want to do. I can't do it. Is what I have to spend 30 minutes before class memorizing. Okay, this is what I write. I write that. All right. What if you found out that was true? This guy's just coming to like hundreds of lines of code he's just memorizing. All right, so maybe you want to do like a factorial example just as a review, and then maybe because I think one thing that maybe helps understand recursion a little bit is building a loop recursively.
Okay.
Because loops are really, it's inefficient, but you can, instead of a loop, you can do something recursively always. Mm-hmm. It's ugly and it's inefficient, but it works. So, for example, if we're doing something like 5 factorial, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. All right? But then, here, let me pump this up on the screen a little bit so it's elevated for everyone. All right? But we can also say that 5 factorial is actually equal to 5 times 4 factorial. And 4 factorial is actually equal to 4 times 3 factorial. 3 factorial is equal to 3 times 2 factorial. 2 factorial is equal to 2 times 1 factorial. 1 factorial is equal to 1. Make sense? So we can express the solution to factorial recursively. That is, factorial can be defined in terms of factorial. 5 factorial is 5 times whatever the current number is minus 1 factorial, so on and so forth. And we finally stop calling things factorial. We stop calling things recursively when we get down to 1, even though we could have stopped at 2, just because anything times 1 is 1, but we'll just go all the way. So once we finally call it on the factorial of 1, we can say, look, enough's enough. The answer to that is 1. That makes sense? So then when we go to write that, we would say, like def fact, and maybe we take in a value n. So we'll ask the question, if n is equivalent to 1, return 1. That's this 1 factorial is 1. That's how we finally finish. That's how we end. Otherwise, return n times fact of n minus 1. 5 times 4 factorial. 4 times 3 factorial. N times n minus 1 factorial. That make sense?
Oh.
Yeah, this is. Yeah. If you're looking for the word for this, this is called recursion. It's another funny Van story. Because Van's a quite good programmer, but he didn't know what the word recursion meant in English. He knew it in his language. So when somebody asked him to solve something recursively, he could have done it, but he had no idea what they were asking him to do. Van's a riot. I love that guy. Huh? You actually wouldn't even need the else in this if you don't want it.
Yeah.
You can just do like that. Because a return statement makes a function immediately end. So we wouldn't still be alive on this line if we died on this line. But the else probably makes it look a little bit more structured. So I'd encourage you to use the else. Nobody's going to be mad at you for the extra line of code. Okay, so does that make some sense? Recursion is supposed to be difficult for you to wrap your mind around right now. All right, so just bear in mind that that's a thing, and that's going to be okay. So even many of you in here who feel like you're kind of ahead of the class in terms of doing the assignments, things aren't as stressful for you, things like that, probably find recursion more difficult. It is a harder concept because your mind gets kind of twisted in those things, which is kind of the advantage early on. I'd encourage you for a while now until you just get bored doing it. And when you're bored, then you know you don't need to do it too much anymore. Always draw pictures or write it out, do stuff like this, because then you're able to see your algorithm. This isn't that intimidating to us. These are just numbers. We've been working with them forever, right? From this, you can then translate it into a working algorithm. If you're just trying to imagine it in your head and you start throwing out, well, do I say if? Maybe I need a loop. All of a sudden, you're just grasping at straws at that point. All right, so let's look at an example of a loop. So let's say I had a function. We'll call this guy loop1, and we'll take it in. We'll take in a value n, for example. And let's say we want to print all the values from n down to 1. We'll walk backwards. So I can say for I in range n to 0, if I want to go down to 1, go down to 0, and then I step by -1, that guy, so that'll walk backwards. So if n was 10, this will go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It'll stop at the 1 because it won't go on to the 0 since that's the extra value. And then each time through here, I'll go ahead and print out I. Right, so this will print out 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. In the example, if I called loop 1 passing at a 10. Make sense? That's what that guy will do. Now let's write loop 2 recursively. Okay, so the idea here is, and let's write some stuff out here. So let's assume I passed in a 10. And I want to keep printing stuff out until I finally get a 1. So if I pass in a 10, that means I should print the 10, then call loop 2 on 9. Print the 9, then call loop 2 on 8. Blah, 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 blah. Print the n, then call loop 2 on n minus 1. Finally, when n is 1, print the 1. So we'll ask the question, if n is equivalent to 1, print n, else actually, we could just always do this. We'll print n, and we'll say if n is equal, we'll say if n is not equal to 1. Is there not? There's a not equal like that in Python, right? If n is not equal to 1, then we'll say loop 2 of n minus 1. So we're calling it recursively now. So loop 2 and loop 1 will have identical output, yet loop 2 is horrifically less efficient. Because every single time we call loop 2, we have to put this version of loop 2 on hold until it's finally done. So we have to imagine in a programming language how you might represent a function. Probably with lots of, like an object of some type that has a bunch of fields and crap like that to remember all the stuff you're dealing with. So it's more complicated than just 3 or 4 strings. Well, now we're saying you get put on hold. Then the next call to loop 2 gets put on hold. Then the next call to loop 2 gets put on hold and starts taking up memory, and what's called the execution stack becomes a problem. All right, so you would probably never write a loop this way, but the point is you could, and that sometimes helps you see recursion a little bit better. Go ahead.
Would that be acceptable for example?
Would what be? I mean, if it works, that's fine. I would strongly encourage you probably not to write your loops that way. I mean, most of you should understand this version of it substantially better. I might even say that 50% of you look at this and say, I'm not even sure why that works. And that's okay right now. When you take 470 and we use scheme, you'll do all your loops this way. Because this guy doesn't exist. It technically actually does exist, the most modern version of scheme, but you're not allowed to use it. You're not allowed to use variables. So all you
So we just cut out variables.
Actually, for most of that class, you don't use variables. You have to juggle variables through your parameter passing.
Ooh.
Yeah, there's technically a way to define variables, but because of the nature of a functional language, you really don't define variables for a while. You get the values by continually passing them through as parameters.
Okay.
Like we're doing here with n.
Mhm.
What's the current value of n?
Okay.
Yeah, that class is a blast. You're going to love that. I think you'll take it as juniors, right? 2 years. You'll take it because it was offered last semester, so it'll be offered in the fall of 20. Is that right? Our next fall is 19, so it'll be the fall of 20. Every other year. So it depends on when you came into the program. You take it either as a junior or a senior. All right, other things you want me to go over? variable scope. Okay. Like I mentioned when we were reviewing, it's a little bit trickier in Python because Python is a loosely typed language. And because of that, the way not only is it a loosely typed language, but it's also an interpreted language. And the way that the interpreter goes through the code makes variable scope less strict. But I like to teach it the way that almost every language you ever work with will treat it. So that is, if I have a variable out here, let's say I is equal to 5, like that. And then let's say I create a function called def do something, and this guy takes in an I, and I say print I. And then outside of here, after that function's over, I say print I again. And let's say I say do something, and I pass 19. I was going to pass it at 10, but 19 is just as good. All right, so I have I is equal to 5. Then I call do something, and actually let me do another print I up here. So I is equal to 5. So we would say that this I has global scope with everything I have highlighted there. So pretend like this is the whole program. So everywhere that I have highlighted, that version of I exists. It's reachable. It's accessible. So we say scope is where can you access a variable. All right, so this variable I up here, this guy right here, is visible to all the lines following it. Okay? So when I print out I here, what's going to print? 5. No harm, no foul. Now I'm calling one of my functions called do something. I'm passing it a 19. Now do something actually has a more local variable called I. And remember that thing we had in the notes that said all variables resolve to their most local definitions? So that says when I say print I here, this I will resolve to whatever this version of I was, which in our case here is a 19. So this will print out 19. Then after this function is done, and I'm back to here, when I print out I, now I is back to a 5. Print out a 5. So that's an example of variable scope.
Question. If I return I and do something, will it print out 19?
Only if you captured it. So if you said return I here, and then in here you said I is equal to that, then you've changed the value of I here. But the fact that it's named I in here and you return it doesn't have any impact on I unless you catch it inside your same variable I.
Okay, that makes sense. Thank you.
Cool? All right, so we're out of time. When's the exam? 10:10 on Wednesday. Wednesday, 10:10 a.m. in this room. If you do have any questions or want me to review anything leading up to that, send me a message on Slack, blah, blah, blah. I am out. I leave for a conference tomorrow morning. I will not be back until Tuesday night, but I will have full access to the internet and stuff like that. If you need to do a video chat or do something on Slack, I'll make myself available. But just know you probably won't find me on campus on Monday or Tuesday. All right? Have a good weekend and good luck on your exams.